Good morning, everyone. Thanks for joining us on Virtual Breakfast. My name is Eric Anderson. I'll be your host for this morning. So I'm pleased to present our first presenter today is Dr. Younsuk Dong. He is our irrigation specialist on campus. He's going to be talking about efficient irrigation water use. So Younsuk, go ahead and take it away.
Well, good morning, everyone. Today, I'm going to talk about some of the strategies for efficient irrigation water use. The first, we need to know how much the water holding capacity, how much soil water holding capacity we have in the field. In order to do that, the most direct method is taking soil sample and send to the lab. Once you send to the lab can provide the percentage of sand, silt, and clay. And using the information with this soil classification chart, we can determine which soil type that we have it. And the soil type is the primary the parameter that determine the water holding capacity. So knowing what soil type that you have for your in your field is very important to determine how much the soil can hold the water. If you have not done any soil sampling and sent to the lab, you can also go to the USDA Web Soil Survey website. Once you go on this website, you can click this little green icon, Start WSS. Once you do that, you can type in the address and GPS coordinate of your field, and this map would direct you, zoom in to your field, and then you have to select the area using the AOI icon. The AOI is the area of interest. So once you do that and click the soil map on the top, the tab, as you see on the first arrow on the top, then it will show you what soil types that you have of the selected area. So for example, this field looks like most of pretty much based on this USDA soil survey data, it shows that this field has Astamo soil, which is sandy loam soil. So you can have this information using this USDA Web Soil Survey website. Here's some other example of one of our demonstration, the field down in Southwest Michigan. So it looks like this field has mostly Astamo soil. But as you see in the upper right corner, it shows 5B, which is spink soil. And spink is classified as loamy sand. So loamy sand are a little more coarse texture, so it's gonna hold less water than Astamo soil, which is sandy loam soil. So once you have the information, we can calculate the available water holding capacity. The USDA website tell you what the available water holding capacity for different depth. So for Astamo, it looks like a top 24 inch. It's showing the 3.3 inch. So top 24. If you have Astamo soil, if you're interested in looking at what's top 24 inch soil can hold water, here's the value 3.3. If you have some crop that go down a little deeper roots, maybe the corn, then top 36 inch water holding capacity is 5.09. So the spink soil is the little more coarse texture than the Astamo. So as you see, the top 24, the spink soil can hold 2.16. So it's less than Astamo. For top 36 inches for spink soil, water holding capacity is 2.64. So of course, it's holding less water than the Astamo soil. So knowing the soil name from the USDA, you can estimate, you can calculate what is the water holding capacity for top 24, top 36. If you have some shallow rooting crops, then you can just calculate for 18 for 12 inches, so forth. So another strategy I would like to go over this morning is the irrigation scheduling. In general, there are two types of method. One is the weather-based irrigation scheduling. which is mostly driven by the evapotranspiration. So how much the evaporation and transpiration is happening in the field, and from the information that we can apply water accordingly. So that's one method. The second method is sensor-based irrigation scheduling. The common method, the common ways to do the sensor-based irrigation scheduling is using the soil moisture sensors. So you can install the soil moisture sensors at multiple depths to look at how the water infiltrated after irrigation or after rainfall. You can also estimate the what's the current available water in the soil. I want to briefly mention there's another method using the canopy temperature. So you can actually measure the canopy temperature, air temperature, and vapor pressure to calculate the crop water stress index. That's another method that you can use to know how much the crops use the water each day, and from the information we can schedule the irrigation. Well, this morning I'd like to dive in a little more on the weather-based irrigation scheduling method. So there's an equation that we have to use. So in order to get the actual crop evapotranspiration, we need to multiply the reference potential ET evapotranspiration by the crop coefficient. So Jeff is providing the reference potential evapotranspiration on this virtual breakfast weather updates. That reference is based on the 4-inch grass and well-drained soil, wet water, and it's unshaded, so it's perfect condition for the for growing for the growing the I guess the grass, and that is the reference values. And we don't grow grass, right? We grow the corn and soybeans. So what we need to do is multiply the number by the crop coefficient, which is Kc. So as you see the bottom on the graph, the chart, the Kc values change over time when the corn and soybean grows. I just want to point out the highest water need for the crop is at the reproductive stages. So from that Kc information, we can calculate the crop evapotranspiration. So if you're growing some other crop besides corn and soybean, you can visit our website to find out what other crops crop coefficient. So we have other crops like alpha or vegetable fruits. You can find the Kc numbers through our website. So where do we get the reference potential ET? The one place you can go is National Weather Service, Weather Service website to get the evapotranspiration. If you're in Michigan, and you can go to the EnviroWeather website to get the RPET. I believe there are over 100 weather stations across Michigan. So from the EnviroWeather group, so I'm sure you can find the one close to your field to get this reference potential ET. The couple thing I want to point out here on their EnviroWeather website, if you go on their website, go to the weather, and under irrigation tool, there is potential evapotranspiration daily summary. So once you click that, you can select the weather station that is close to your field, and click the date and select the date where you like to see the evapotranspiration. And they have a little function start accumulating. So for example, if you like to know weekly evapotranspiration, how much the evapotranspiration was occur last 7 days, then you can select the date, 7 days before, prior to that dates to, and the website can accumulate the numbers for you. So in this case study, I picked the July 4th, and I was interested in looking at the weekly ET, so I picked the June 27th. So it started accumulating from June 27 and up to the July 4th. It looks like that for 7 days, the accumulated ET is 1.454. So you can do that. You can get the weekly ET using this website. You can also sign up. I believe the Keith Mason went over how to sign up for getting the text alert through this EnviroWeather website. So you can create an account. You can sign up for getting email or text for the evapotranspiration values from the weather station that you're interested in. So I'd like to give you some example of calculation. So how do we use these numbers? So RPT, we got 1.454 from the EnviroWeather website. I have two of our demonstration field. The one corn is at the VA stage. The other soybean field is at the R1 begin bloom stage. So first, we need to get the reference ET, which we did here. Then we have to multiply by the crop coefficient. So the crop coefficient for corn, the VA stage is about 0.8. So we multiply 1.454 times 0.8. Then it came out the 1.16. So all the reference ET shows 1.454. The corn at that VA stage from the June 27 to July 4th, the water use came out 1.16 inches. If you have soybean and your soybean is at the R1 stage, then the crop coefficient is 1. So basically the same as the reference ET. So we got the 1.45 inch. So if you have soybean, it's R1. If you I believe the 1.454 is from the Constantine weather station. The weekly water uptake for soybean that time during the June 27th to July 4th is 1.45. So if you have different weathers, different location, if you're in different location, they use different weather station to get the reference ET. I want to briefly talk about scheduler program. So we have a scheduler program that you can download for free and use it. You can, there's some inputs that you have to put in, what soil type you have, what crops you're growing, emergent state, which is important. And you can select the closest weather station to the field, and the program can automatically download the evapotranspiration data, and it will download the rainfall data as well. But if you have the rain gauge, that you can always just type in too. So and override the numbers. So that's something you can do. Want to talk? So this year we've been putting the soil moisture sensors at different location in corn soybean field, and I want to just show the data. So this data was collected from June 25th until the July 4th. Looks like the half-inch water in this sensor is in East Lansing, Michigan, here South Campus, South Farm here on campus. The half-inch application, the June 26th wet the soil top, wet the soil. I guess it looks like all the way down. And the 1.3 inch is also that we got over the weekend, wet the soil all the way down. So. But keep in mind, this field is been irrigated a couple times in May. So this has higher moisture when we start higher moisture content in June. We have another sensor set down in Takansha, and this field got 0.9 inch water on June 18. That really impact all the way down to 3 foot and 6-10 inch impact on up to 1 foot. And they over the weekend they only got 0.15, so 1500, and that really didn't do any. They didn't wet the soil down at 1 foot. So, but want to mention this is also in irrigated field. They applied 7/10 in May. and 3/4 inch sometime in June. So they've been keeping the soil moisture high. I'm sure if you're not irrigated, if dry land farming, the soil moisture may be a lot different. Here's the sensor data from Union City, close to the Takansha, also shows similar trends. And when I mentioned the over the weekend, the 1/10 inch application did not really impact the 6-inch depths, the moisture. So here there's some some tips we always provide is if you irrigate it, make sure you give the large volume, but consider that what soil you have, what the capacity you have, but larger volume will be beneficial. So make sure all the water goes down deeper so that you pretty much recharge your profile. Really briefly, when I mentioned the irrigation system evaluation, so we do suggest to do the uniformity testing, maybe once in every other years. So make sure the irrigation application is uniform as possible, as much as possible. Also, we suggest do some flow testing before the growing season, maybe sometime during the growing season or at the end of the growing season. See how the water, whether you have enough capacity, enough flow is going to the pivot. And the right photo, the Eric's been flying drones over the center pivot to look at to identify which sprinkler are having problem or having some issues or potentially having some issues. Here's some photos that Eric took from using the drones. Once you have the uniformity data, we can plug in this evaluation tool to get the system uniformity coefficient. If it's less than 85, we just take a look at the center pivot as sprinkler, find any potential problem. Here's some data. I'd like to share some case study at the top. This graph is the uniformity, the graph. So y-axis the volume. So how much volume that we collect from each can. The x-axis are the distance from the center. The top is the uniformity before they change the sprinkler. And their sprinkler is a little over 7 years old. And they knew they had some problem with the uniformity. So we did the evaluation, catch-can test, uniformity test before they changed the sprinkler. And we did another test after they changed the sprinkler. So you can see there's big improvement, big improvement and good learning about having this uniformity data. So we highly suggest, and if you are interested, have someone doing the uniformity, please feel free to email me or Lyndon. So we'll be happy to talk how we can help with the uniformity testing. So.
All right, let's move into our Q&A. Had one question come in, and Younsuk has already taken care of that in the chat, but you can address it now as well. What are the units for measuring water holding capacity?
Yeah, so unit for water holding capacity is just inch of water per inch of soil. So per inch of soil, how much water is in. So
is that essentially the same as percent, or is it different?
Yep, you can just convert to percent. Yeah.
Okay. Question. This is probably an enviro weather question. So the most of the sites will have for soil moisture, they'll have 0 to 12 and 12 to 24. I know, Jeff, you showed for Hazlitt there were actually 3 sensors.
Yes.
Do most of them only have 2?
They do, and and there's a long story behind this. It has to do with the changing technology, but some of the original sensors we only could put 2. That was the most room we had for on the data loggers, and so we used the top 12 and then the second 12 inches as layers. The standard, the international standard for this looks at actually at 5 depths, going down to a meter or a little over 3 feet. And so we are in the process with EnviroWeather of trying to change our network, but it's slow going. And as Younsuk knows very well, the putting especially probes down at 39 inches or a meter down is a logistical issue in getting a big trench. So it's changing. And this is something we need to work, I think, collectively together to look at what depths. But a standard international would be 4.8, 20, 50, and 100 centimeters, or 4.8, 20 inches, and then 39 inches would be the international standard for this. But it depends on your system. That's looking at it not primarily maybe at irrigation, but just as a monitoring tool for volumetric soil moisture. So it's in a state of flux, and I apologize for that. We're trying to get things on the same page, but it's going to be, I think it's going to be a continuing, fairly lengthy process to do. We've got 100 sites to do this.
So for 0 to 12, where is that sensor? Is that at 12?
It's actually looking at the whole, the volume. So it's the average across the top 12 inches of the profile. And when we started, that's sort of the logic that we used because of the technology that was available. But it's an average for that top 12 inches.
Okay. The next two questions are probably also weather related. So Jeff, can we expect to see a return of Canadian smoke in our forecast?
Well, you would, based on what we saw, we hope we don't see anything as bad as what we saw last week. That was very unusual. But what I would note, some of the smoke that we've seen so far this year had to do with this very unusual upper air pattern with these cutoff troughing features, not unlike what you saw in the forecast. And that's one of the only ways that we can get airflow in the lower parts of the atmosphere out of the north and east. And of course, that's where some of the smoke that came into last week originated in Northern Ontario and even Quebec. We've even had smoke from the Canadian Maritimes, which is physically really difficult to do when you think about it, how far away into the east that is. But that upper air pattern allowed that to happen. We may be seeing, it's possible, and it's a long way to go next week. But with that type of upper air pattern, we may see it again. And the other major factor here, the big one, is there are over 400 forest fires still. Some of them are out of control, still burning in Canada. Unfortunately, there's still lots and lots and lots of smoke there. It's just going to take the right, again, trajectory with lower atmosphere to get it down here. So the guess is right now, certainly we have not seen the last of it, but hopefully it won't be as bad as what we observed last week.
So given the forecast that you gave for next week, of course, one of the questions folks have is for the wheat that's coming off, is next week a good week for harvesting wheat? Well,
there's always the half full and half empty. And I think this is the empty part. I think, again, most people would welcome the water, but in terms of wheat harvest, the timing here is not great. And unfortunately, not only are we looking at it, just the number of opportunities, and it's not strong probabilities. That each day we'll see like a 30 or 40% chance, and of course that really complicates things. Trying to make some proper decisions. It will be. I think it'll be trying that way, especially looking at next week. The first 3 or 4 days of the week, almost a daily chance. So that's going to be tough. And I think that forecast suggests more of that. At least for the next week to 10 days. So that, while again, the water for many will be very welcome, in this case, it's going to be a challenge.
Okay. So I've got a couple of interesting questions in the chat that actually might be good for Younsuk for you to share your screen to answer them. But before I get to that, this is probably a good segue. Marty Chilvers, our field crop pathologist, dropped a note in here about maybe some potential fungus in wheat. Marty, you want to talk about that?
Sure. Yeah, thanks to Mallory for getting that up on the MSUE news site. So I had a call yesterday and I've seen some myself just walking around campus, just some black sooty mold on the wheat. now that things are mature and we actually have had some rain, it's resulting in just the fungi that are naturally occurring, just developing on the outside of that wheat head. So it really shouldn't affect quality too much. Most of that should just blow straight out the back of the combine as the grain gets separated. The only note to that is we may see a little bit of black point, which is where there's a little bit of sort of infection or coloring on the very tip of the grain. But there's an article in the chat there too to have a look at.
Okay. Let's see. Any other specialists? Chris DeFonso, our field crop entomologist. Yep, she's on. Chris, did you have any insect updates you wanted to add?
No, I actually did want to ask Marty. This has been a good aphid time in May and June, and I did wonder. I had a couple calls about aphids on wheat heads, and there could have been some sooty mold there earlier too. That from their honeydew. So I did wonder if the aphids are gone, but because the crop is drying down, but might there be some sooty mold from some aphid infestations as well?
That's a good question, Chris. And I don't know the whole role there, the aphid element, but I mean, yeah, I'd imagine if we have other plant exudates on the heads.
Yeah, I just wondered if that explains some of what you were seeing.
Maybe some of it. So one of the calls I had yesterday was some lodged wheat and some very sort of severe sooty mold in that. And just walking campus, I didn't notice any aphids in our wheat here. But, again, because of the moisture and that head's already dead, you just, it's no different to leaving something in the fridge for too long, right? Just things starting to develop. But certainly if there was heavy aphid infestation, that could certainly add to the issue.
Yeah, and we didn't have rain to wash off any honeydew, which you'd normally have if there's aphids there. Mm-hmm. So I think people were noticing those aphids a little bit more. This rainy kind of pattern, if you get a little bit of humidity, then there's some natural fungi that kind of take over and kill aphids. And then we're also ramping up some of that biocontrol. And that biocontrol that was produced on the aphids in wheat move into soybean and corn fields in the next couple of weeks. So you'll get a little influx of biological control. I don't think I had any Western bean cutworm in my trap yet, but there may be a few that are just starting to emerge. And then I have had calls about aphids in hay, which I presume means alfalfa and not the grass hay. And I'm going to need those specimens is what I'm saying. So if you are a person who's had, for the last month has had persistent issues, I kind of have a suspicion, but I cannot confirm my suspicion without an identification. I know that sounds very mysterious, but I didn't want to say more. So if you are someone who has sprayed twice or 3 times and they just won't die, if you can get aphids to campus, winged and non-winged, both winged ones are like gold because that's good for identification. And then there's a few of you that I'm going to follow up with after this breakfast.
Chris,
So
is there a region of the state that's been reporting that?
No, it was, like about a month ago, I got a few calls. Why won't these aphids die? Some of it was down in Eric's area in the southeastern part of the state. Now it's kind of central part of the state. There's more than one aphid on alfalfa. There's probably 5 that you'd say are kind of like pests, but there's something called the blue alfalfa aphid that's invasive. And to my knowledge, I know it flies into our suction traps. There's evidence that it has flown here, but I've never seen a field with this aphid. It came from California and is now came into California and has moved west to east. So I just have this terrible feeling that maybe that explains what's happening, because it is a species that's known to be hard to kill and very resistant. But I need to do ID first. So anyway, thus the need for aphid specimens. And you can never give me too many. If you can get these specimens into ethanol, which means vodka if you have it or something like that, or even rubbing alcohol, a lot. Don't give me 3, give me 3,000. And then maybe we can get an identification. Okay.
That is why entomologists are interesting. Easy to give a Christmas gift. Well,
We are strange
3,000
people. I
aphids.
know that.
That's
But plant
all I really
pathologists
need.
are strangers. So I'm just throwing that out there.
Very nice. Thanks, Chris. Thanks, Marty. Any other specialists have anything that they wanted to add this morning? Let's see. Mike Staten, our soybean educator, I think might be on. Mike, do you have anything you wanted to add this morning? I'm not seeing anything. Let me come back to a few of the questions for you, Younsuk. There's actually a few of them, so feel free to go as in depth as you want here.
Yeah.
For most of your presentation, you were talking about, just the top, basically the rooting zone. I've got a question here. Is there a program or a map that shows geological information for well drilling?
Oh, okay. So maybe I'll come back with the soil survey. So, well, if you want to know existing well location, you can go. The Eagle has the Well Logic website. You can find it. But if you're into potential irrigation well drilling, or maybe if you're looking to drill a new well, is that the question is, or?
I think that's what they're looking for, drilling
Okay,
a new.
Okay, then you do have, so Michigan, you do have to go to water withdrawal assessment tool. Have to drop the link here in the chat. This help you to identify whether you can pump certain amount of water capacity at that location. So you do have to run this water withdrawal assessment tool. And there's a little more information here, A, B, C, D zones, A, B, so once you plug in all the information, pick the location, how much water you're gonna pump from that location, and if they came out that is zone A and B, then you're good. You can just submit. You're most likely not likely impact the stream fish population. If you're in zone C, then the Eagle may come back to do some site-specific review. And if the result came out with the zone D, then you probably won't have the area probably won't have a capacity to withdraw that amount of water. So we have some more information about water withdrawal assessment tool on the website. So feel free to stop by the website and take a look at it. If you have more questions, just email to me. I'll drop my email as well. Yeah.
Okay, and that question came from Jordan. So Jordan, I also dropped in. Dr. Hassan Ghani is our drainage specialist. He may have some information about deeper depths on his website, so you can contact him. And Mike tells me that he is now unmuted. So Mike, did you want to chime in here quick?
Yes, Eric, thanks. And sorry about that technological problem. I just wanted to talk about double crop soybeans briefly, or answer any questions about double crop soybeans. There's always interest in that. And so at this time of the year, so I guess the key is get the weed off as early as you can, get the crop planted as early as you can. Kind of a deadline is the 10th. The crop insurance deadline is actually the 15th, but the practical agronomic deadline is kind of the 10th from the growers I've worked with over the years. You want to plant a variety that's probably either one full maturity group to a half a full maturity group earlier than you'd normally plant. Plant that at higher seeding rates in narrow rows. And those are really the big practices that you want to accomplish. I would really recommend avoiding fields that have a known history of soybean cyst nematodes because you are effectively shortening your rotation. But it's a risky practice, but it is an insurable practice in Michigan. And I think you have until the 15th of this month to talk to your crop insurance salesperson about that.
Remember that the second crop soybean is like candy for aphids.
Chris, thank you. That's
because it'll be
important.
the juiciest, newest growth out there, as the other soybeans are kind of starting to go past their R stages, and sometimes those just get hammered hard and hammered early. So just reminding people of that.
Very important reminder. I really appreciate it. And that's actually my last bullet in the article I wrote. So if you want these information on this, it's in MSUE News. I think it was published last Thursday. So look for an article on double cropping soybeans.
Great. Thanks, Mike. So Younsuk, I know you had pulled up a website. That might be a good one to end. I've got a couple of questions, hopefully quicker questions that you might be able to answer. Are there soil texture classes or crops where using tensiometers or TDR probes may be preferred?
So the TDR, just based on my experience, it works well any type of soil. TDR, we don't see any issues. Only like tensiometer or any sensor that use suction, suction lysimeter or some suction mechanism to measure. So the tensiometer, watermarks, those tension sensors, they really have to be somewhat moisture, somewhat wet, and you do have to have good tension, maintain the tension. So what we seen was that when tensiometers sensors in the sandy soil, which can be, the moisture can be fluctuate really well, really largely. It can go into dry really quickly. Some weeks that you will lose the tension. Then you have to pull it out and create the tension and put it back. So so that requires, so tensiometer probably not preferable for if you have sandy soil, but TDR you can use any type of soil.
Okay.
I can, yeah. Yep, go ahead.
You can leave that up, but I've just got one more quick question for you. Phil says he's got producers that are applying limited amounts of irrigation, maybe like 0.6 inches a week to clay loam soil. And they're wondering if they're getting enough water to provide benefit for yield in forages.
So it would be really great if we have some sensor, soil moisture sensor, to look at how much moisture level changed over time. Maybe and so I think I'll suggest do some monitoring, soil moisture monitoring in the field. Another way to look at it is the weather information. So you can use evapotranspiration and crop coefficient for the forage, and how much that water is really uptaking, and how much moisture in the, how much water capacity that you have in soil. Just do a little balance, the equation to look at whether the 0.6, 0.6 per inch per week is enough, or maybe you don't need it that much. But I think it's really dependent on the weather and the a particular stage of the crop. Yeah, we have to talk to Bill maybe with the potential monitoring at the site.
Okay.
Yep.
And for those of you who have not opened your chat this morning, there's lots of folks who have been dropping in different links. So if you haven't opened that up, feel free to do that, and you can probably just copy and paste the whole thing in there so you can get all those links that people have been referring to. This may be our last question that you'll be able to handle for today, but Alan is wondering, you had mentioned getting some specific information out of the web soil survey. So he's wondering how to navigate to the soil water holding capacity part of the website.
Yeah, well, thanks for the question. I should have addressed this during my presentation. But so once you select the area of interest, click here Soil Data Explorer and click here Soil Report, and then go to the physical soil property and hit the View Report, View Soil Report. And if you scroll down here, it will show all the soil type of the area of that you're interested in. And over here, the raw water capacity inch per inch is shown here. So you can get the information from under Soil Data Explorer, Soil Report, Physical Soil Properties, and hit the view soil report.
Great. Well, that's a perfect example of why we're here on Thursday mornings, not just to provide information, good information, but also to answer your questions. So thank you, Younsuk and Jeff and all of our specialists for coming on this morning, answering all the questions that came in. And we'll hope to see you all next week.